Good evening, learners. I am Professor Pallavi Joshi, and today I have come up with a short but very important concept, that is recursive functions, basically well known by the name recursion. Students, this topic belongs to unit number 3 of your PPS, which is functions and modules, right? But still, recursion or recursive function does not only belongs to Python programming. It is the important method of all programming languages like C, C++, Java. So in short, we can say it is a programming construct or a programming concept, which alone Python doesn't has a special significance. So let's begin with recursive functions. So when we talk about algorithm or in the same way, if we talk about functions, there are two basic types of functions. First is iterative functions and second is recursive functions. The same is applicable with algorithms also, iterative algorithm and recursive algorithm. Purpose is same here for iterative type and recursive type. Purpose is same, the method makes a difference. In iterative functions, we iterate a block of code n number of times using iterative or looping statements. The looping statements like for loop, while loop, etc. based on any condition. So this block of statement is iterated n number of times based on the condition is true or false. Whereas when the function solves a larger problem or a bigger problem by calling itself n number of times, make a note, a function solves a larger problem by calling itself n number of times with variance in its parameter, and that too actual parameters we are talking about, each time. So now this makes a normal function as a recursive function. I'll repeat. So when a function calls itself n number of times with the only difference in the parameters, that too actual parameters each time, so this type of functions are called as recursive functions. So a short definition, or we can say a bookish definition of recursive function is as follows. A recursive function is defined as a function that calls itself to solve a smaller version of its task until final call is made, which does not require a call to itself. Every recursive function has two major cases, which are as follows. So here once again the same thing is highlighted. When a function is calling itself again and again, recursive functions has two cases. We have a base case. So a base case is in which a problem is simple enough to be solved directly without making any further call to the same function. So one function is being called by a main function with a parameter say n. So this function is, as soon as the function call is made, interpreter will search for the function definition. In function definition, it will sense that n is the actual parameter which was passed, and now this will become a formal parameter. The function will execute its dedicated task. At the end, the same function will call itself by passing the parameter n-1, or we can say with some different condition. Now this is making the sense. So when we call the same function again and again by just making change in the parameter, and that to the slightest change, this makes a normal function a recursive function. And now what is this base case all about? A base case is such a case wherein a function need not to call itself again the next time. Now this is the last case which will stop the function's execution. If you remember, I have explained you the merge sort example, which is again the divide and conquer example. In the merge sort, we need to solve, or we need to sort a given array. So sorting was done based on dividing the larger problem into smaller number of problems, and we go on dividing the larger problem into smaller problem until and unless the problem is no more divisible, means it is in its indivisible form or atomic form. So that atomic form is a base case for merge sort. So if you remember, we have stopped when we have divided the sorting the array into the individual elements, and then we have started merging the solution for that individual elements to its parent, and then in turn to its grandparent solution. So the same case is applicable here with the base case. And the second case is a recursive case. Now the recursive case is a normal case in which the problem at hand is divided into simpler subparts. So only two things need to be taken care. So recursive function, where we are calling the same function again and again, this will be our recursive case. And when we reach to a case where the function need not to be called again, where the function will be executed in the simple normal case, when in our case, say suppose when n becomes 1, so that time it will be a base case. Recursion uses divide and conquer technique for problem solving. So thus it is clear that recursion uses divide and conquer strategy of problem solving. If you remember, we have already studied two strategies of algorithm or programming. First is divide and conquer, of course, which recursive is following, and another one was dynamic programming. Now here you need to make a note that base case is very important in recursive function, because if we forget to give a base case, the program will go into infinite number of steps, which is not true to the features of algorithm. We know that algorithm or a function, it needs to be stopped at some or the other condition. So when there will be no condition, it will go into infinite mode, and that is not desirable. Let's take an example. So the program you can see is about finding the factorial of a given number. So the first statement you can see is definition of fact, but the interpreter will not go into the definition at this moment. First thing an interpreter will search for is the call to a function. We have discussed this earlier n number of times, that in spite of n number of definitions in the program, interpreter's job is to first of all search for the function call. If there is no call to a function, all the function definition will be wasted. So the first statement after the function definition is n equal to int input, enter the value of n. So the user is expected to enter the value of n. Say suppose n ka value is 5. The next statement is print. The printing will be executed. The factorial of n is. This statement will be as it is printed, because the factorial of, so this is a string enclosed in double quotes, it will be printed as it is, comma, next, comma and n. So we know that n is now integer type. The factorial of was string type, and we can separate them with either converting the type or by the comma. And the next part of that print statement is call to a fact function. So here fact is called with a parameter n. Now you can see as soon as the fact is being called, interpreter will directly jump on the definition of fact. Now definition of fact also accept the same actual parameter, the parameter which was passed by function call. So n is the same parameter. Second step, or inside the body of the function, the first step is the condition checking. If n equal to 1 or n equal to 0. In both the cases it will return 1, because factorial of 1 is 1 and factorial of 0 is also 1. So now if we have taken n equal to 5, then the condition is false for our case, and we will directly jump on else part. Else part says return n into factorial of n minus 1. We know the function either returns two things. Either it returns the control to a calling function, or it returns the value. Now here we are supposed to return some value, but then where the value will be returned? N into factorial of n minus 1. So n, we know the value of n is 5 and fact of n minus 1. So again this, immediate after the multiplication, we are recalling the fact function again and again. For the first time we are calling by n, for the second time it will be called by the parameter n minus 1. So return 5 into factorial of 4. So when I say fact of 4, again the definition will be called fact of 5. So here will be 4 this time. Again n is not equal to 4. So it won't go inside this if, it will again jump to this else part, and now it will be return 4 into factorial of 3. Factorial of 3 के लिए वापस function call, it will go into the definition. If condition is not true, else it will jump on else. Return 3 into fact of 2, and likewise it will be 5 into 4 into 3 into 2 into 1. As soon as n becomes 1, it will enter the if condition and it will return 1. Okay, so you might get confused that where we are going to store this n value each time whenever there is a function call to its lesser number of, whenever the function is called again and again with lesser number of arguments. So we'll have one more separate lecture for that. Till now, as of now, you just understand that there is a stack. Stack is a data structure basically. We'll explain it to you later in the coming next lecture. So stack is a data structure. System stack is used here to store the values which are in process. So n, right from n ka value is 5, then 4, then 3, then 2, then 1. All these values of n are stored in this system stack, and the stack is responsible for the value which is entered last. It will be the first to come out. So first 5 into 4 into 3 into 2 into 1. So in this reference, the values will be returned, it will be multiplied, and it will be printed. And hence we'll get the output. When the entered number is 6, we'll get the output 720. Same program, just the cases are handled differently. So def recursive factorial, if n equal to 1, so interpreter will not go into the function definition. It will first of all search for the function call. So outside the function definition, which is the first statement, num equal to 7 is the first statement. It is checked if num is less than 7, so print this. Else if num equal to 0, print. Else print the factorial of num is, and the function is called recurse factorial of num. So num is the parameter and n is the formal parameter. If n equal to 1, return else return n into recurse of factorial. The methodology is same. Another program to display Fibonacci sequence. So again, the program begins with the definition, but interpreter will first of all search for the function call. So the first statement outside the function definition is n terms. So n term is the value which is 10. So we need to find out first 10 numbers ka Fibonacci series. If n term is less than equal to 0, print this given message. Else print Fibonacci sequence, and for I in range n terms, print recursive. So recursive Fibo is a call to Fibonacci function. So where I is the actual parameter, it will be n in the function definition. If n is less than equal to 1, return n. Else return recurse of Fibonacci of n minus 1 plus recursion of Fibonacci of n minus 2. So we know that Fibonacci of any number is Fibonacci addition of the Fibonacci series of addition of its two earlier numbers. The last program of reversing a number in Python. So we have one variable which is a global variable. Reverse equal, we have a variable reverse equal to 0. Def reverse integer, but we will not go into the definition. Why? Because we have not received the function call. Now number is taken from user, reverse is being called, so this is a function call, and lastly when the function will be executed, this will print the reverse number. So in function call, what is happening now? So global reverse, it is been made globals once again. If number is greater than 0, remainder is number into number mod 10. So we want the last digit. This statement is giving me the reverse, the last number, and which is stored in the reverse num ka variable, which is the latest variable. And here I am recalling the reverse function again and again with the lesser number. So if 1, 2, 3, 4 was the earlier number, now 4